Hi, everyone. My name is Chris Bly with Insight Up Solutions, and we are a drone reseller here on the Central Coast. And I've had the pleasure of working with the next three presenters, Pat and Ben and Dale. And they have all very interesting things to share with us regarding what is generally known as lift. And you know, using multi-rotor drones are great for a lot of applications, but with lift, we can achieve greater distances and be more efficient. So looking forward to hearing from our three panelists. So we'll kick it off with Pat.
Thanks, Chris. Everybody hear me okay? Can everybody hear me?
Yes.
Okay, good. My screen is not sharing. Can you see my screen?
Yes.
Yes.
Great. Hi, everybody. Welcome to the winding down of Thursday afternoon drone camp. I know everybody's probably a little saturated by now with all the drone stuff we've been doing. So I'm going to be very brief. I have no data to present or results to show you. I just would like to give a little overview of fixed wing aircraft and vertical takeoff and landing aircraft in particular, because we really didn't have time to address that much in the equipment roundup day that we had. Again, my name is Pat Iampietro. I am the Geospatial Technology Officer at CSU Monterey Bay, where DroneCamp was actually supposed to be held in person this year, but of course we're all doing what we can. I'm also the coordinator of the drone program at CSU Monterey Bay. So anybody who is associated with CSU Monterey Bay and interested in learning how you apply to get a flight request in or any of that information, you can reach me. So we talked about this on the equipment roundup day. I guess that was Monday, a little bit, but the question is, why fly fixed wing aircraft? There are definitely pros and cons to the different types of aircraft, but the main one being that the fixed wing aircraft, as Chris was just saying, because the aircraft can glide and take advantage of lift, can stay up in the air for a lot longer. There's an old adage in aviation that helicopters don't really fly, they just beat the air into submission. And doing that beating really takes a lot of energy, it takes a lot of your battery time. And so where you might only get a 30-minute flight in with some of the modern quadcopters today, aircraft like the EB can easily do 90 minutes in the air. And that translates, depending on your altitude, that can translate to a couple hundred hectares covered in a single flight. Whereas with a quadcopter, you would be hard pressed to even do a quarter of that. So they have longer endurance, which means you get more area mapped per flight. And some of them have a larger payload capacity. You could fit a larger DSLR on a fixed wing than you can on some of the smaller rotary wings. If you want to put a big DSLR or a hyperspectral camera on a quadcopter, you're probably looking at something the size and weight of a Matrice DJI or something similar. Some fixed wing aircraft can fly in slightly harsher conditions than a rotary wing. They can tolerate a little bit of rain. They can tolerate more wind in some cases if you fly in the right direction. And finally, when a fixed wing, because of lift, when a fixed wing's motor fails or the battery dies or something like that, it rarely will plummet out of the sky like a quadcopter will. When a quadcopter's rotor stops spinning because the battery fell out or you ran out of juice, it just comes straight down, whereas a fixed wing can glide and often save your aircraft. That comes with some cons though, of course. You need a lot more room for takeoff and landing of a fixed wing, unless you're using a vertical takeoff and landing aircraft. The aircraft can't hover. So if you are interested in doing real-time inspection of a building or power lines or something like that, a quadcopter is maybe the more appropriate tool because you can, get up close and hover and look at individual parts of the subject, which you can't do with fixed wing just flying over. Depending on the type of aircraft, I think Sean said it well when he said the other day that with an EB, every landing is sort of a semi-controlled crash landing. There are no landing gear or anything on that aircraft. When it comes in, it skids to a halt on whatever surface you landed on. And if that happens to be grass or something, that's great. If it's asphalt or something less forgiving, then it does put some wear and tear on your aircraft and on the prop. They typically, fixed wing aircraft are much more challenging to fly manually. And in fact, in many cases, the manufacturer, for example, with the EB, we owned an EB for a month or two before I found the secret compartment in the case that had the Xbox type controller in it. And then there was a warning there saying, you know, don't try to fly this by hand because it's very difficult. The FireFLY Pro, which we'll see on the next slide, is also a pretty squirrely aircraft to fly by hand. And you really have to be careful about wind. In some cases, fixed wing aircraft are probably, I would say, more likely to require a PC laptop as opposed to a mobile device like a phone or a tablet as your ground control station. So there's a couple different main types of fixed wing aircraft. There's the flying wing design, which we saw the EB, and the one to the right of that in the picture is the bird's eye view FireFLY 6 Pro, basically just a wing shape. The Wingtra is another sort of flying wing type design. And then there's standard fuselage with fixed wings like the Trinity F90 Plus that we're going to hear about in a little while. When it comes to vertical takeoff and landing, there's two main strategies that the aircraft use to do that. And one is a convertiplane or a tilt rotor, where you have rotor blades that actually can rotate. For example, in the FireFLY Pro, there's a strut that goes through the middle of the fuselage, and there's actually a little sprocket and chain drive attached to a motor that rotate the forward props to a forward position for forward flight. So you can take off straight up, and then when you want to transition to forward flight, you push a button on the controller, and those props rotate around and carry it forward. And landing you can do in reverse. Another notable thing about the FireFLY Pro is that it actually does have landing gear. It has little wheels, and they retract when you take off and then come back down again when you land. So that's the convertiplane or tilt rotor type of VTOL. And another strategy is called a tail sitter. And that's an aircraft that you set it up on the ground, pointed straight up with its props up straight up, and you hope it's not too windy, so when you walk away from it, it doesn't just blow over. And then it will take off straight up like a helicopter and then transition to flight, not so much by rotating the props, but by changing the control surfaces so that it will go forward and fly like an airplane. Several of the offerings in the fixed wing category come with RTK capable GPS for higher precision mapping. The bird's eye view FireFLY Pro that's in that picture has RTK, as does the EB as an option. RTK GPS it will afford you a much higher precision in your mapping products. And it's definitely a good addition. The payload capacity on these, as I was saying before, is generally a little higher. We have a 42 megapixel Sony DSLR that goes on the FireFLY Pro. We'll also be mounting the MicaSense Ultim on that aircraft. The EB we have has a much smaller point and shoot DSLR or point and shoot digital camera in its payload bay. So really what I wanted to do is give you guys all a kind of a rundown of the different types and designs of fixed wing, both VTOL and standard aircraft, and how they can be used to do mapping missions with much greater efficiency in some cases. So I will turn things over to, I guess, Ben is next.
Yeah, great, thanks, Pat.
Hey, everybody, you got me? Can you hear me?
Yep.
All right. Well, thank you. My name is Ben Erwin. I'm a RV pilot with Monterey Bay Aquarium Research Institute. And today I'd like to tell you about MBARI's interest in using aerial platforms such as fixed wing drones to conduct marine science. Some of the applications and motivations for MBARI's interests include bio-oceanographic processes, such as long transect time series studies, tracking harmful algal blooms, studying animals like jellies, fish, birds, and whales. Also ocean and atmosphere interactions. Other interests include spotting entangled wildlife like whales, pictured down below, and water chemistry. There's some tracking of marine debris and chemical spills, public outreach, and taking nice images, locating assets on the surface, like our autonomous underwater vehicles. When they resurface, we can use drones to spot them and recapture them. And also using drones as a data relay for deployed assets like moorings and wave gliders. Some of the requirements that we've come up with is a system that needed to have suitable payload for common imaging gear. They needed to have a functional range of around 70 kilometers, which would get us across the bay and back, at least Monterey Bay. It needed to have appropriate launch and especially recovery options while at sea, and accessibility to flight data and payload control. The solution we came up with after trialing some systems was to build a robust kit plane from a very cheap online source. We chose the Believer platform. The cost of the full build of the Believer is around $2,000 and takes around 12 hours of build time. The maximum flight weight is approximately 5 kilograms, with 1.5 kilograms of that being payload. So during our testing, some of the measured performance we saw was with a weight of 4.5 or 4 3/4 kilograms, we estimated we could get about 85 kilometers on a 16 amp hour battery, 6S. The average airspeed during that test was, or during those testing phases, was around 20 meters per second. The Believer has really easy access to all the hardware and software. It has customizable payloads. The cost of repair was minimal at around $250 for the entire body kit. And the spares and replacement parts are readily available from multiple commercial vendors. The basic electronic infrastructure of the Believer is a standard PixHawk and Mavlink workflow with extra connections for power and payload interfacing. Some of the payload options that we're looking at using are the Sony cameras, the Sony A6000 series, and the RX1, R2. Of course, Red Edge multispectral imagers, hyperspectral imagers. We're looking at using directional signal tracking for locating assets. We're looking at using gimbaled HD cameras and directional antennas as well there. Also hardware such as computers for creating the data relays with our deployed assets. And then finally, thermal infrared imaging. The control system consists simply of a Taranis X7 open source radio controller. It operates on 2.4 gigahertz and has bidirectional data on and configurable switches and pots and joysticks and all that. The software we use, we've actually been trying a few, but it's compatible with any Mavlink control software such as Mission Planner, Q Ground Control, Pix4D, and Drone Deploy. Some of the future developments that we're working on with our next series of aerial platform is, so the Believer 2, are optimized internals and electronics for more efficient flight, at least energy usage during flight. We have a waterproof imaging port seen here with this RX1 R2. There's a vibration mount that connects to that for the Sony cameras. We have an HD first-person video transmitter. There's increased, we're expecting increased range with a ground control station and directional tracked antennas. There's a ping RX ADS-B detect and avoid system we're about to try. Deployable parachutes, the ability to support multiple imagers for simultaneous data acquisition. This means being able to correlate infrared data, for instance, with RGB data or a high resolution camera. And then the possible addition of using lithium-ion battery packs as opposed to lithium polymers for increased energy density on the plane. Some of the concepts of operations for marine science, because it is a unique environment. How do we deploy a plane from a small boat or a ship? Well, the process begins with planning. Are the targets near shore or are they offshore? If they're near shore, they don't require necessarily a chase boat. If they are onshore or if they are offshore, they do require a chase boat. For us, we have to, if we're operating within the marine sanctuary here, we have to submit a flight plan to NOAA. And then, of course, we launch the plane, perform our flight operation, and then a choice of landing. And so based on whether we're flying off of a ship or the small boats, we can land with this plane, either belly landing in the water. Since it's waterproof, we can just go pick it up, deploy a parachute and use the parachute as a grab point, or we can fly it through the A-frame of the flyer, which is pictured here, this is our ship, into a net that we deploy onto the A-frame, just fly it right into the net. After, of course, the flight operations, we conduct data processing, download the data, and then create science from that. And then finally, at the end of the year, the sanctuary requires us to submit a report based on all of our flight information and give them access to that. And that's really what we have so far.
Yeah, great, Ben. That was a really good presentation. I want to learn how you put yourself as a true presenter in the corner there. That's awesome.
Oh, I can teach you that later.
Yeah. So I have a couple questions, mainly around, because we do a lot with airspace management, and you said ADS-B, detect and avoid.
Right.
So maybe tell me something about that.
Yeah, so built into Mission Planner is a detect and avoid sort of prototyping that they've started to implement. And so a company called Ping ADS-B, I can find the link and post it later. They've created a low cost, it's about $200 for this receiver. It receives signals only from ADS-B sources. So like if you have a Cessna that's transmitting on the frequency and it detects it on board, it can actually send that back to, well, actually, I think the processing happens on board the Pixhawk, but it can, if it breaches some geofence, it can perform some maneuver, whether that's a parachute deployment or an avoid. It can certainly it can do that. So we're still looking at how well that works, but we've tested some we've tested some of it on the ground. We've seen the planes come into the Mission Planner map, and we can do a simulation where we can see the plane likes to avoid it, so it performs its safety maneuver. So there's online, if you check the forums and such, there's some question as to how reliable it is, but there's certainly work being put into that. So
great, yeah. Well, I know that we're also looking at using some radar and things like that to get another perspective on unmanned craft flying out over the bay. So that could be another perspective on flying beyond visual line of sight. And then also on that same topic on waivers, have you guys pursued any FAA waivers for beyond visual line of sight?
No, we haven't pursued that yet. The pandemic kind of put a hamper on a lot of our plans this year. So we'll soon get back into it where we can start preparing for that. There's quite a process to getting all the training manuals. There's like manuals you have to have put in place to do all the BVLOS stuff. but that is on the long in our long game plan, because of course being able to just run out to the beach, toss the plane in the air, and let it go do its science and come back to us is really ideal, than rather than chasing it with a boat for half a day. So
yeah, that's the dream. Yeah, and hopefully we'll get there. Well, thank you, Ben. Yeah, I'm always impressed with Mbari science and what you guys have worked on, and underwater and now above water. Very exciting.
Thank you, Chris. Yeah, thanks for all your help with everything too.
Yeah, definitely. Well, next we have Dale that's going to jump on. We're a reseller of Quantum Systems Trinity, and very impressed with their craft. So Dale's going to give us an overview of that.
Hi everyone, how are you guys doing? So everyone can see the screen?
Yes.
Okay, awesome. So Quantum Systems is a VTOL manufacturer or UAS manufacturer, larger frames. The idea is that they are all made in Germany, which is a little bit different than many of the other drones out there. The idea was to take the ease of use of multi-rotors and the long range capabilities of fixed wing drones, and then get rid of all the bad stuff of those to create a platform that is easy to fly. So we get easy handling, vertical takeoff and landing, long endurance, and high flight speeds. I'm gonna just do a quick video here since it seems the embed didn't work. And give me a second. And I don't know if, is that showing full screen or it's not?
It's not.
Okay. Why? There we go. The idea is it takes only about 5 minutes to assemble the drone, and you do use a PC to do the mission planning. But as you can see, I actually don't have the remote in my hand, and I just am using the computer to launch it. And it just takes seconds for it to launch and go off out to its mission. So from a technical standpoint, the Trinity has a flight time up to 90 minutes. In reality, it's actually over 90 minutes, but we conserve some of that energy for landing and returning to home. It's approximately a 10-pound payload or 10-pound aircraft. It cruises at 17 meters per second, or roughly 38 miles per hour. It can cover up to 700 hectares, and for those in English, that's around 2,100 acres in a single flight. Depends on the sensors and the payload that you are flying with. It is limited to about 700 grams of payload, and we have specific ones that are integrated into the system. There's a wind resistance up to 9 meters per second, or for roughly 26 miles per hour. Now, this is slightly lower than a lot of people like to see, especially if you're flying a multi-rotor and you're on coastal areas, because obviously it gets pretty windy in the coastal areas. But the problem is if you're flying an aircraft, fixed wing aircraft, and you're capturing that nadir data, if you get too much winds, you're going to be not capturing straight down data, and that makes it quite difficult. A couple of things that it includes is anti-collision lights. It is PPK capable altogether, and as our last presenter was indicating, the USB ping is integrated into this system as well. It is very great for capturing anybody who's transponding, which is every aircraft is supposed to be doing that now. But sometimes you do run across helicopters who are not transponding, and they're flying actually at like 300 feet. So you do have that controller capability to be able to take control rather than the EB, which stays in the box. It does have the ability to actually control without crashing the drone. Like you can't push the stick so far down that the drone's going to actually go straight down and crash, or turn to the left and flip upside down. There's no barrel rolls or anything like that. Primarily, it is flown using the flight planning software. It weighs approximately, in the case, approximately 40 pounds, let's say, with one battery in there, and less than 50 pounds with 2 batteries. The primary payloads that are integrated at this time are the Sony UMC, which is a 20 megapixel camera, the RX1, R2, which is a 42 megapixel camera, the MicaSense Red Edge MX, and the MicaSense Ultim. And there's also a dual payload capable with the Sony UMC and the Red Edge MX, which allows you to capture high resolution RGB imagery along with that multispectral imagery. You get a 2.6 centimeter resolution with at 100 meters altitude with the UMC. RX1 is 1.2 centimeters, so it's quite high resolution. I do have to say that the amount of data that you collect, each image is approximately 35 to 45 megabytes. So as you're flying large areas, you do get a lot of data. I flew an area down in Florida for an airport, and we had a 75-minute flight, and that ended up with about 55 gigabytes of data in a single flight. You do have the Red Edge MX, and a lot of you guys are using this multispectral sensors already. And then you have the Ultim, which adds that higher resolution camera and sensor for including the thermal capabilities. And then just recently we added in the MicaSense Red Edge Dual that's fully integrated into the system. And I know a lot of you guys are interested in this for the coastal reasons. I've also had, actually 2 days ago, had NOAA up here in Seattle area where we were doing some training on the Trinity. So they are definitely interested in having this kind of information themselves. And we had a number of discussions about how to fly off boats. I'm just going to flip through some of these quickly, but there's proof that you can get high accuracy information without actually using ground control points. And again, if you download the slides, you can dive into these a little bit more. The big thing about the Trinity is you have that minimum flight time of 90 minutes. You have easy to use payloads, high quality RGB, high quality multispectral imagery, and then easy to take off and land, and high wind resistance compared to other VTOLs. In terms of flight planning, it's super easy. If anybody's ever flown an EB, they'd know eMotion. Even some of the mission planners are similar. There is a 3D elements to this. There's a recent update for this, for Cubase, that added in the Imperial system as well. You basically pick your aircraft, you pick your payloads. Generally, you don't have to mess with the speeds, but you can fly anywhere from 17 meters per second to 20 meters per second. So if you need to get something done a little bit faster, you can do that. Or if you have higher winds, the drone will compensate for that. There's also includes STRM data for those areas using Esri up to 60 degrees north and then all the way down to South America. And that info is really good for areas where you're needing to, especially in California, you could easily fly the coastlines and have it step up for each leg it goes up. You do want to fly parallel to the areas, otherwise the legs won't actually follow that. You can easily program in areas as well as corridors, and you can fly multi-leg sets, meaning you can fly an area, then you can fly a corridor, then you can fly an area again, or you can fly multiple corridors. It has weather forecasting built into the software that helps you with your mission planning. And then this is an example of the ADS-B receiving that you can have. There is options also for ADS-B out. If you have the proper authority to broadcast that information, you'd have to get the clearance from the FAA for that. And again, you have PPK capabilities, and that also works with the multispectral imagery as far as processing. And that's all I had for that. Would be happy to answer any other questions too.